In this exercise, I want us to talk about what we would need to do to the original graph to graph each one of these that I have listed for us. Okay, so this is going to be like a quick exercise for us to make sure that we have an understanding about transformations, about vertical shifts, horizontal shifts, reflections, and stretching and shrinking. So here's my original graph, 2 to the x, okay? So if 2 to the x is your original parent graph, what was added to number 1 here? I'm going to start with number 1. Well, I see that minus 1 has been subtracted at the back. So to get this number 1's graph, we would need to move the original graph down 1. This is a vertical shift down 1. Okay? Number 2, going back to the original. If you have 2 to the x and then you have 2 to the x plus 1, I see that a plus 1 has been added to the exponent. So if a number's been added or subtracted to the exponent, this is a horizontal shift. And for a horizontal shift, they go the opposite that you would think. So adding 1 says move every point to the left 1. So again, I'm always going back to the original 2 to the x and comparing the original parent graph to my new graph. All right, let's look at number 3. Again, going from 2 to the x to 2 to the x plus 2. I see that 2 has been added to the very back. So this is a vertical shift. This one would go up 2. So we would graph the original 2 to the x, and to find this 2 to the x plus 2, we would take every point of the original graph and move it up 2. All right, let's look at number 4. Number 4's graph. I see that a number has been added to the exponent and a number has been subtracted at the back. So this would be, adding 2 would be a horizontal shift to the left 2, and minus 1 is a vertical shift down 1. So to graph number 4, we would take the original graph 2 to the x. We would move every point to the left 2, horizontal shift to the left 2, and down 1. Okay? Number 5, very similar to number 4. I see we're subtracting 1 in the exponent and subtracting 1 at the back. So this minus 1 in the exponent, this is a horizontal shift to the right 1. This one right here. This one here is a horizontal shift to the right 1. And then this one, this minus 1, is a vertical shift down 1. So again, everything derives from the parent graph. You would graph the original parent graph 2 to the x. Then you would take every point. To find number 5, we would go to the right 1 and down 1. Every point, right 1, down 1, right 1, down 1. And then connect the points and you will have the graph of number 5. All right, now let's talk about number 6. Well, again, remember that the original graph was 2 to the x. So what has been added here? A negative on the front. So anytime you add a negative, this would be a reflection on the x-axis. So you would take every point of the original parent graph and you would reflect it over the x-axis. Looking at number 7, if a negative has been added to the exponent, this is a reflection over or on the y-axis. Okay, you're reflecting over the axis or on the y-axis. So if your original was 2 to the x and you've been asked to graph 2 to the negative x, you'll take every point and you'll reflect it over the y-axis to find your new graph. Look at number 8. A number has been multiplied times the front. Anytime you have a number multiplied times the front that is greater than 1, This is what we call a stretch, okay? To find the ordered pairs of a stretch, you will find the ordered pairs of the original, 2 to the x. Then recall, you keep the x's the same, and you multiply the y's by your scale factor of 3. So we would find our newly stretched ordered pairs by multiplying the original y's times 3. So every y will change of your ordered pairs. The x's stay the same, okay? So this would be a stretch of 3. And the last one, number 9, g of x equals to 1/2 times 2 to the x. Remember, if you multiply a number on the front that is a fraction times the original, 2 to the x, this is going to be a shrink of 1/2. Okay? So again, to find the ordered pairs of a shrink, we would take the original order pairs. We would keep the x's just the same. But to find the newly shrinked y values, we would multiply every one of the original y's by 1/2. So we would shrink each y, multiplying it by 1/2 to get our ordered pairs of our shrink. So I just wanted us to talk about and look at all the different transformations that can come from the original 2 to the x.